So hi guys. So today we go on 7.7, no, 11.7 and 11.8. So we have counting principle, uh permutation and combination. So for example, we have 40 people in this classroom. Support we select two people from the class complete the national started tournament. The first one is the leader. The first one is the leader, and the second one is assistant. So how many different ways select and the people? So I just give out the example like A. Oh, like I can say P, that is Pamela, A, Alexa, E, Aaron, J, Jessica, and T as a Tom. So we can have all this stop right here. So the leader, so in here, um 40 people, right? So the total for 40 people. So N is so we got N is 40. So the total is 40 people right here. And we have um like select a number of select. So we selected two people, right? So right here we selected two people. And does for number three, does the order is the matter for arrangement matters or not? So for example, I pick out the leader, either I pick the first one, I pick like Pamela, and then Erica for assistant, or I can switch to the to um Erin and Pamela. So this one is does the yes, right? Because it does matters, right? Because we need one leader if in the 40, so we have one leaders in the 40 and also one assistant. So this one we can say yes, yes for does matter because so this one as we can have as uh permutation, permutation. So this one is called permutation. Um, or or we can say or we can have as so we can have this order is matter. So we know is order, yes, is matter because we need that one person of this, one person is not a one. So yes, order is matter. Okay, so it's order matter. Either one because if you pick Pamela or Erica or Alexis or Aaron or Jessica or Tom, so yes, we can put either one. It matter. So this one we can select, and if we select the leader, for example, if we select for Aaron, so we have another one. What we have only so this one is, must be 40. So if we select one person here, so we have only 39 more to select with assistance, right? Yes. So this one should be the auto matters or the permutation is um, permutations. So how about for the second one, let's change the general one, one again. We need select only two people again in this class. So we still select two people in this class, but this time if there's no leader. So this time is there no leader. And also there is no time. Oh, this one should be for them. So no title for them. We just select two team member and how many way we can select sub the people, right? So this one is we still have total four, see, and we still select as two. Um, so does order is matters? So does the order is matters or not? So this one is no. This one is no matter, no matter for the order. Either one you can pick out like a Pamela or Erica for leader or Erica for or Aaron for the second people they because they don't have a title. They don't have a title. So this one we can have as so this one is combination. Combination. So this one is combination. Um, and also this one is so we can say if order does not matter. So this one, if we go in here, this one is order does not matter. So it doesn't matter whatever that we can rearrange that. So this one we call combination. Um, so this one for in here, so we can say um, so this one uh, permutation, permu- permutation. So this one permutation, yes, it permutation, yes, the order rearrange give out the object. So we select R of the end item, so no representation is the same, cannot be selected more than one. Um, remember for permutation, so we can select more than one for one item or one person. We consider uh, rearrange of the same items in a different sequence in a permutation A B. We can select from B A and occur separately. So so this you see this. So this one, this is the one. You say explanation mark right there. So this one is we call factoration. Factoration. Let me type it in. So this one is factorial. Factorial. Tor re factorial. So that's one is factorial. Okay. Factorial. For this example, the top one, we have so P of 40 and pick out two. So this one is 40 factorial over 40 minus 2 factorial. So minus 2 factorial, or we can say 40 factorial minus 38 factorial. So this one should be, we can Either one we can use with a calculator or we can use with this. So factorial means like what? 40 times 39 times 38 factorial, and then this one 38 factorial. So you see this factorial is gone. So now we got 40 times 39. So we should have as uh so so we should have 40. So this means like 40 times 39 up 40 times 39. So 40 times 39 is what? Whatever you try to do it, or we can cancel this one out. Okay, and for this combination, uh, hold on, combination, let me change to the red color for you can see it. Com combination, so combination, okay. So combination is distinct of a group. Is the things of the group or the set to object which are regarding order, a rearrangement. So there is R n different item. We select the R and N, and we still do the same thing. But that is the formula for that. So this one is this formula. So we can say so 40. So this one C, which is 2. So the difference between this one and this one is for this one we have to divide all factorial, but this one is not. So you can see this. So this one 40 over so 40 minus 2 factorial, or we can say 40 times oh, and then also we have 2 factorial. Sorry about that. 40 times 39 times 38 factorial. And this one 40 minus 2, though this one 38 factorial. So if 2 factorial, say 2 times 1. So we can say this one gone. So this one divided by 2. So this one 20. So we have what? We have 20 times 39, which we have 780. And then over here, so the top one, we get 40. So we can see this. And this one 40 times 39. So we got so we have 1560. So that's how we're doing that. And we have a formula divide. You should see the order matter. Permutation, yes. Combinations, no. They have all that stuff. So we have example number 1. So we can see. So we can see this. A, B, C, and 2 letter been select. How many different way the letter rearrange matter? Order matters. Remember, order matters. So this one is the highlight is order matter. Okay. So we have if the order matter, what does that mean? Permutations, right? So this one is permutation, permutation. So this one is permutation. So we have what? N is 3, right? Because only 3 letter and R is 2. So which one we use? Permutation. So this one we use right here. So this one we got P2, no, actually 3. 3 to 2. So we got 3 factorial um over 3 minus 2 factorial, or we can get 3 factorials over 1 factorial. So 3 times 2 times 1 and divide by 1. So this one is 6. So this one's 6. How about for this one? And for this one, we have combination. So this one combinations, and we can do the same thing. So this one's N is 3, R is 2. So we pick on combination. We pick this one, right? Okay. So now we get 3C to 2. So 3 factorials over 3 minus 2 factorials times 2 factorial. So we can get 3 factorial should mean that 3 times 2. So this one is 3 factorial over 1 factorial and 2 factorial. So 2 factorial, so 1 times 2 factorial. So this one is 2 factorial. So this one equal 3. So this one is 3, right? So for next example, Nancy had 10 different flower. So Nancy 10 different flowers. Um, so right here is 10. So 10. So N is 10. So 10 different flowers. Okay. And then they choose 2 to use, 6 to 6, from 6 to use. So R is 6, right? So which one we use? So this one, it doesn't matter. Okay, doesn't matter. So so right now we have N equal 10, R equals 6. So doesn't matter what is that? Combinations, right? So if they doesn't matter, so this one should be combination. So this one is combination. So we have to indicate that's combination. So if combination is 3 to 10 and 6. So this one is 10 and C 6. So this one should be 10 over 10 and 10 minus 6 factorial times 6 factorial. So we can say 10 factorial over 4 factorials and 6 factorial. So this one is 10 times 9 times 8 times 7 times 6 factorial, and 4 times 3 times 2 times 1 and times 6 factorial. So 6 factorial gone, and this one done, right? And 3, so this one 3. So we have what? 10 times 7 times 3. So we have what? We have 10 times 3 times 7. So this one is 210. So we have 210. Now I can show you how to, so you can see is how to do with the calculator. So here, and let me clear all this stuff. We do the same thing, math, and we still do the prop. And you see this, number 3. So number 3 right there. So CN. Just hold on. Let me exit this one out. Just hold on. Let me quick. Because they have what? 10. I forgot that. Either one. I can do 10 first or I can do 10 later on. It's okay no matter what. So 10 and pick out 6. So we can enter. See? So it's the same. 210. Okay. So for number 3, if the club have 10 member, so this one a 10 member. So how many different way after they select rearrange president, vice president, and second terrace as possible. So this one is what? Um, right here is the order. Doesn't matter, right? But this one, the order is matter. So this one should be the orders matter. So so this one is the order matter. So this one, so this I can say this one is the order matter. Order matter. If the order matters, mean what? So what is that? So it's the permutations, right? Permutation. So if this one permutation, so we can have what? So for one, uh, N is 10, 2 is R is 3, and 3. So this one is 10, pick 3. So P of 10 to 3. So we had a formulas already, 10. So this one 7. So actually this one is 10 minus 3 factorial. So this one is 10 factorial. So 7 factorial. So we got 10, 9, 8 times 7 factorial. So you can cancel that. So 7 factorial. So 7 factorial, 7 factorial. So we get, so this one we have what? 720. So this one we have a 720. Because that's one is matter. So if you want to use a calculator, so we can bring up a calculator. So because this one 10, so I put 10. Oh, by the way, what if I don't want to, by accidents, I do not put in the front first, so I can still do it. Math, go to the prop, and go to the P, right? Number 2. So number 2. So you see that this one bling bling bling. So I put number 10, and you see the arrow. I move to here, so I get number 3. So enter. You see this? I still get the same numbers. Either one you can do by hand manually, or you can use the calculator. Either one is big. Either one been good. So we can have that either one. So now for number 4, there's 20 member on the board directed Long Beach General Hospital if they must have sub committees committees of a 4 member. So how many sub communities are the possible. So we have what, 20 members and 4 members. So this one is orders matter or doesn't matter. So this one should be no matter, right? Does not matter, right? So this one, no. So if they order no matter, so what we have? So if the order no matter, so we have combination. If a combination, so if that is the combination, so this one is order does not matter. So order does not matter. If the order does not matter, so this one is n equal 20, r equal 4, and combination, so we use c, so 20 of 4. So c 20 of 4, so this one is 20 factorial over 20 minus 4 factorial and 4 factorial, so we get 20 factorials over 16 factorials and 4 factorial, right? So this one, as we can use, is 20 times 19 times 18 times 18 times 17 times 16 factorial and 16 factorial times 4 factorial. So 4 factorials means 4 times 3 times 2 times 1. So 16 factorial is gone. And so we can reduce this. So we can see this. So 2. So if we can cancel 2, um, 2, 18. So this one is 9, right? 9 and 3. So this one 3. So this 4, this one 5. And then that's it, right? So this one we got 5 times 19 times 3 times 17, which we got 48, 45. So 48, 45. And we can do with a calculator if you want to, but this one you don't have to do the 48, 45. So now for this example, the example number 5. So we have a 20 member. There's the 20 members on the board of direct in the Long Beach General Hospital. If they must to the first elect the chair person. Okay, first a vice chairman, second vice chairman, and secretaries. So how many different ways they can do the possible? So this one is what, as we know. So this one is permutation. So this one is permutation. Permutation. So if this one permutation, so this one is the order is matters, right? So order matters. So if permutations, the order matter. So now, if the orders matter, so we can have what? So N is 20, R is 4, right? Because we have right here 1, 2, 3, 4. So we have 4. So permutation, so 20 to 4. So P of 20 to 4, we have 20 factorial. So 20 minus 4 factorial. So we got 20 factorial over 16 factorial. So we got 20 times 19 times 18 times 17 times 16 factorial. So 16 factorial. So this one cancel. So we have after we multiply everything, we get 116 280. So we have the next one. There are 15 dogs entered to the show. They can first, second, and the third place award. So what do you think for this? The place award. So this one is order matters, right? So because they need the first one, they need the second one, they need the third one. So yes, this one is the order matter. So this one is the order matter. Order matter. So if the order matter, this one a permutation. Permutation. So if this one order matter, so this one is permutation. So if permutation, so this one is N 15. So R is 3. So permutation. So this one 15, pick 3. So we got 15 factorials over 15 minus 3 factorial. So equal 15 factorials over 12 factorial. So 15 times 14 times 13 times 12 factorial and 12 factorial. So we can say 12 factorials cancel out. So we got 27, 30. So 27, 30. And the next example, in how many way you can respect the letter A, B, C can be rearranged. So we can do what? A, B rearrange. So this one we have N is 3, right? N is 3 and R is 3. So this one is what? Order matters, right? So this one is order matter. So this one is order matter. Order matter. So if this one order matters, what is that? Permutation. So if permutation, so we can say P pick 3, 3, right? So P 3 pick 3. So this one is 3 factorial over 3 minus 3 factorial. So this one is 3 factorial over 0 factorial. Remember this, 0 factorial equal 1. So always 0 factorial equal 1. So 0 factorial equal 1. So this one is 3 times 2 times 1 over 1. So this one is 6. So this one is equal 6. Okay. So number 8, how many way can difference A, B, C, no, A, B, A can we rearrange? So how many way we can say this? This one is first A, B, A, and we can get A, B, and we can get B, A, A. So this one is total 3 letters, right? So this one they can be 3. So we have 3 factorial over 2 factorial. So this one 3 factorials. So this one we have as, so this one is total 3. So 3 total, 3 total letters. So 3 total letters, right? And right here we have what? 2 A's. 2 A's. So, this one, so this one is, and this one is, okay. So this one equal, we had 3 times 2 times 1. So this one 2 times 1. So this one is 3. So we have this. So we have, okay, for the permutation rule, when the sum are identical to other, so they are the n item available and some item identical to the letter and to select all the n item, we consider rearrange distinct number different sequences. So right now we can do with what I can let me go with this. I should be make this one bigger, and I should be make this one as this one. So Tennessee. So we have a Tennessee, right? If a Tennessee, and I can rearrange for this one as I can do this as even ENTSENS. So we can say 1, 2, 3, 4, 5, 6, 7, 8. So the total 8. So we have a 8 factorial over. So for the E, how many is that? For E, 1, 2, 3. So for E, that is 3, right? So this one is 3 factorial. This one is for E. And 2 factorial. So this one is for N. And 2 factorial. This one is for S. And then 1 factorial. This one should be for T. So this one we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over. So 3 factorial. 3 times 2 times 1. Good. So right now I have 2 and 2 factorial. So times 2 times 1 and 2 factorial times 2 times 1 and times 1. So we have this. So we can see this 3, 4. So this one, and then also we had 2, 2. So we done. So if we do auto calculation, so we should get 1680. So this one is 1680. Okay. So, example, in how many way we can the letters sort by statistic rearrange? So we have how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the total is 10. So this one is 10 factorial. So that is 10 factorial. So we have start with the S. S. So S, how many is that? 1, 2, 3. So S is 3. So 3 factorial for S. And we start with the T. So how many T? 1, 2, 3. So we have also 3 factorial for T. So 3 factorial for T. And then we have what? I. I. So how many I's? 1, 2. So we have 2 I's. 2 factorial. So this one I. And we have a C. So how many C's? Just only one C. So this one we can do as the calculation. So we can say 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over. So this one is 3 times 2 times 1, 3 times 2 times 1, and 2 times 1 and times 1. So this one gone. So we got 6, right? So this one 6 is gone. And this one we still have as, so this one we still have as 10 times 9 times 8 times 7 times 5 and times 2. So this one should be as 50, 50, 400. So 50,400. So now we have 50,400. Um okay, so you can either one you can practice on this one. Okay, so you can practice on that one. So all the rest is, and thank you very much.